All right, Chapter 8, 4.5 chapters to go. You can thank the half chapter to the 8 billion snow days and late starts we've had this year. And then we'll find out at the end of quarter 4 what we're going to do there. We're going to have to get creative with things. So, Chapter 8 is all about rational expressions. If you're good at factoring, this chapter is going to be very, very straightforward. If you struggle with factoring, you're probably going to have to do a little more work on the front end to make things happen. But today, 8.1, very straightforward in terms of things. Multiplying and dividing should be very easy. So we're just going to take a look at the very first kind of general explanation here. So multiplying polynomials, we're going to do this very similarly to numbers. So when I look at this situation and I have the 8 over 12, all right, how do we reduce it? Well, 8 is 2 times 4, 12 is 3 times 4. I can take out the 4 and reduce to 2/3. We do the same thing with rational expressions. So we have a polynomial on top and polynomial on the bottom. The idea is we want to factor the top and bottom and take out any factors that are the same. Very similarly to taking out the 4, we can take out the x minus 1s. They go away. We're left with x minus 3 over x minus 5. Okay? And that's how we're going to simplify expressions, and then we're obviously going to go on to the domain as well. But let's just jump into our first example down here. All right. We want to simplify, and then it says state any restrictions on the domain. Okay. So first things first, we want to look at the top. Is the top factored? It looks like it is, so we're good here. The bottom, can the bottom be factored anymore? More specifically, this part of the expression. Well, let's give it a try. Are there two factors of 6 that give us a sum of -1? Well, sure enough, -3 and +2. Because then you end up either y squared. You have -3y plus 2y is -y, and -3 times +2 is -6. So now we have the top completely factored and the bottom completely factored. What I want to do before I simplify is I'm going to jump right into my domain restrictions, okay? The reason I want to do this before I simplify is because we have 3 pieces on the bottom. We want to make sure that we state those restrictions. Keep in mind in math we can't divide by 0. So anything on the bottom, we don't want our denominator to ever be 0. So the first part, we know y can't be 0 because y is 0. Okay, got that one taken care of. Y minus 3, well, what number minus 3 is 0? Because that's not going to work either. Well, we know y can't be +3. And then finally, the last part of the bottom, what number plus 2 is 0? Well, we also know that y can't be -2. Okay, so once we have it factored, it's easy to jump right into the domain restrictions, looking only at the denominators, all we're concerned with at this time. Then what you can do is go back and simplify. So you can see we have a y on the top and bottom. We have a y minus 3 on the top and bottom. And my expression simplifies to 4y plus 4 over y plus 2. And that's your final answer. So we took out the common factors and then simplified from there. Okay. Very similarly, we're going to skip over part B, very similar to A. But if we have something like this, okay, again, begin by factoring your expression. So what can I take out of the top? What can I factor out? Well, it looks like both terms have an A and a B. And what's left is b minus 5. On the bottom, it looks like that expression's already factored. If you notice, this part of the bottom looks really similar to that part of the top. What's the only difference in this case? Hopefully you notice the signs are different. You have a +5, -5, -b, +b. So what I'm actually going to do on the bottom, since those are really close, is I'm going to factor out a -1 from this expression, because then I'm going to get b minus 5. And this goes away. So then we have negative 1, 5 plus b and b minus 5. Again, I would jump right into your domain restrictions before you simplify. Looking at your denominator, there are two restrictions to be concerned about. One is negative 5 and one is positive 5. And I'm not talking about x, I'm talking about b. All right? If I plug in a negative 5 to this first piece, it's going to be 0. If I plug a positive 5 into the second piece, it's going to be 0 as well. So those do not work. After you simplify and go into the domain restrictions, well, then you can simplify. The b minus 5's cancel. We are left with ab on top, and then we have a negative 1 times 5 plus b on the bottom. I get this question a lot of times, do I need to distribute back in the 1? No. Today you can leave your expressions in factored form. You don't have to expand and simplify. All right. Continuing right along, that was simplifying. Now we're going to look into more multiplying and dividing rational expressions. Well, first things first, multiplication. Keep in mind, order does not matter when we multiply. Okay. So sometimes when I see all this, it's really confusing to look at. But if I want to put it in a specific order, I have a squared b, and let me just reset actually. We're actually going to put all of the numbers together. So we have 12, 14, a squared b c cubed d squared. Remember, order of multiplication doesn't matter, so if I want to group the numbers and variables together in their likeness, it's going to make my life a little bit easier. Then we have 8 and 21. We have a, b, c squared, d. So sometimes this helps people just kind of see how things are going to simplify from here on out. So if I look, all right, it might be easier to even break up the numbers as well. 12 is 3 times 4. 14 is 2 and 7. 21 is 3 and 7. And 8 is 2 and 4. And sure enough, check this out. We have a 2, 3, 4, and 7 on the top and bottom. So what's going to happen to those? See ya. See ya. They all go away. All right. Then we just have to simplify the variables from here. If I have 2 a's on top and 1 on the bottom, 1's going to cancel. I'm going to have 1a left on top. 1b on top, 1b on the bottom, they cancel. Looking at my c's, I have 2 on the bottom and 3 on the top, which means I'm going to have 1 left on the top. Same with the d's. If you wanted to do properties of exponents, you could do that as well. What is 2 minus 1? Well, that's d to the first. And that's your final answer. Again, order of multiplication doesn't matter. You can simplify, you can move them on the top and bottom however you want to make your life a little bit easier. All right. Moving on to the next example where we have more, or actually this one's just division. Same idea, but if you remember, it's from elementary school, probably actually middle school, your teachers would always say, dividing by a fraction is easy as pie, flip the second and multiply. So we're going to flip the second when we're dividing, and we're going to multiply. It's going to make my life a little bit easier in terms of things. And then from there, you can simplify as best you want. All right, so sometimes you don't have to rearrange things. I won't rearrange on this question. We can just pick and choose. How many times does 7 go into 21? Well, 3. And then 16 over 24. 8 is common. That's going to reduce to 2/3. Okay? So now I can start making my tops and bottoms. If I look across the top, the only number I have left is a 2. On the bottom, it looks like I have a 3 and a 3. 3 times 3 is 9. All right, then I want to combine the m's. I notice there's 1 on top, 3 on the bottom, which means I'm going to have 2 left on the bottom. Okay. I have 2 a's on top, 4 on the bottom, which means I'm going to have 2 left on the bottom. 2 b's on top, 3 on the bottom, which means I'm going to have 1 left on the bottom. And then it looks like I have 2 t's up top, none on the bottom, so we wind up with t squared there. And again, if you wanted to have them in a different order, that is a-okay. So with monomials, single term expressions, no addition or subtraction on the top and bottom, pretty straightforward in terms of things, okay? We can get a little trickier as we have expressions, all right? So again, first step on these, you'd want to factor to make your life easier. So it looks like I can take a 4 out. I'm left with 2x minus 5 on this one. On this next expression, I'm thinking about 2 numbers that multiply to positive 10 that give you negative 7. Well, how about negative 5 and negative 2? All right. So the top is now completely factored. Now we have to look at the bottom. What 2 numbers multiply to 35 and give you positive 2? Well, how about a positive 7 and a negative 5? Again, you can see the factoring we're doing right here is pretty straightforward. There's nothing too insanely complicated about what we're doing here, okay? Keep in mind, when we take out the 4 in this expression, we wind up with a difference of squares. So you want to watch out for those patterns because Ms. Brostrom and I will throw those in from time to time. So now we have our expression completely factored on the top and bottom. When we multiply, again, just like before, we want to simplify. So if you notice, we have an x minus 5 on the top and bottom. We have an x minus 2 on the top and bottom. We have a 4 on the top and bottom. And then we can simplify. All right. Makes your life a whole lot easier. And again, you don't have to FOIL anything out. You can leave it in factored form. All right. Continuing right along to our next slide, we just have a couple more examples, but I think, to be honest, we should be good if we just do part B, okay? So we'll zoom in on part B, and we'll finish this one off, and then we'll go from there, all right? So, first things first, we want to factor. Remember, when we factor, we have difference of squares, so we wind up with x plus y, x minus y, all right? And then this part, we already did that, we wind up with y plus 7 and y minus 7, okay? So the top is completely factored. Again, like we just said before, division, when we divide by a fraction, easy as pie, flip the second and multiply, all right? So the complex fractions, they look complex, but they're really actually pretty straightforward, all right? Again, just like before, if you notice, 2 of these look really similar. We have an x minus y and a y minus x. So we're going to use that strategy we talked about before, and I'm going to factor out a negative 1, which means I'm going to wind up with a positive x and a negative y. Okay? That's going to make things a lot easier when we go through because the x minus y's drop, the y plus 7's drop, and then I can simplify from there. So my final answer in this case, we wind up with, x plus y on top, and then on the bottom we have a negative 1 and y minus 7. Okay? So complex fractions look pretty complex, but to be honest, they are just the exact same thing as division. Flip the bottom, multiply, make your life easier. Okay? So that's today. A lot of factoring, a lot of simplifying, multiplying and dividing should be pretty straightforward. Your assignment's here. Best of luck on things. Let me know if you have any questions.